Hello everyone. Today we are going to see a new topic from theory of machines, balancing of several masses rotating in different plane. So here you can see two figures. The first one represents balancing of several masses in a single plane on or in the same plane. Whereas the second figure, it shows, you can see the axis of rotation. These are the different planes and masses. Okay. So this one is balancing of several masses rotating in different planes. So we are going to see one example from this balancing of rotating mass in different plane. Okay. A shaft carries four masses A, B, C and D of magnitude 200 kg, 300 kg, 400 kg and 200 kg respectively, and revolving at radius of 80 mm, 70 mm, 60 mm and 80 mm in planes measured from A at 300 mm, 400 mm and 700 mm. The angles between the cranks measured anticlockwise are A to B 45 degree, B to C 70 degree and C to D 120 degree. The balancing masses are to be placed in X and Y. The distance between the planes A and X is 100 mm, between X and Y is 400 mm and between Y and D is 200 mm. If balancing masses revolve at radius of 100 mm, then find their magnitude and angular positions. Okay. So based on the given question, we have to first write the given data. So we know the four masses given as mass A 200, mass B 300, mass C 400, mass D 200. Corresponding masses radius are given in terms of mm. You have to convert in terms of meter. Okay. And these are the distance between the mass and the reference planes. Okay. So this Rx is the radius for the balancing plane, okay, which is X and Y, and the distance between the mass and the balancing planes are, here it is 100 mm and between X and Y it is 400 mm. Now we have to follow some steps. Okay, next I will show the steps to follow for constructing the balancing masses for the given several plane. Okay, so first you have to write the given data, then draw the position of planes and draw the angle of position of masses, then assume the reference plane. Here you can see from the reference plane to the left we have to consider it as negative, to the right it should be considered as positive. Then you have to form a table. Okay, so whatever you have drawn from position of plane and angle of position, based on that you have to form a table. Then based on the table you have to draw the coupled polygon and force polygon. Okay, so these coupled polygon and force polygon, it purely depends on the number of unknowns. Based on the number of unknowns we are going to draw coupled polygon and force polygon. Finally you have to measure the balancing masses distance and angular positions graphically. Okay, so we will first write the given data first, and we have written here already. I can show here, this is the given data, so we have completed the given data. Next we have to draw the position of planes. So I will just roughly explain how to draw the position of planes, then we will draw the angular position of the masses based on the example, okay, available data. So here you can see, so number of masses and its corresponding radius are given. Okay, the masses and the corresponding radius are given. So you have to place all the things. So totally four masses. First draw the axis of rotation line. Okay, then you have four masses A, B, C and D. You know the weight of each masses and corresponding radius. Here the radius is given in terms of millimeter, you convert in terms of meter. So I will take this as first mass 200 kg and I am going to represent the first mass 200 kg here. Okay, and corresponding radius here. Then second mass, third mass and fourth mass. At the same time you can see the distance between the masses. So you can see measured from A at 300 mm, 400 mm and 700 mm. Okay, so you have to position the masses. So You can see 200 it is drawn as A, then 200 to 300 second B mass is at a distance of 300 mm. So this is mass B. So distance between these two is 300. Okay. Next, then B to C, the distance is 400. From A, next mass is here, this is C. So from A the distance is 400. Okay. Similarly, you have D mass 200, that is at a distance of 700 from A. Okay, all the masses we have to draw with respect to A position. So D is 200 kg at 700 mm. So this is A position. From here you have to take 700 mm and draw the D mass. Okay, so this is 700 mm. Next you have to introduce the balancing planes, that is X and Y. The distance between the planes A and X is 100 mm. So A is here and X is here somewhere. So this is X plane. So the distance between these two is 100. Okay. Next, X and Y is 400. X and Y. So here it is X and Y is 400. So it will be somewhere here. So from here to here it is 400. Okay. Between Y and D is 200. So here it is Y, this is Y, and between Y and D this is 200. Okay, this is how you have to draw the position of planes. After drawing the position of planes, next you have to construct the next one. What is next one? Here you can see position of planes is over. Next, angular position of the masses. So for angular position of the masses, I will just show how to draw. First, fix a point here. Okay, first mass you take it as horizontal. This is mass M1, corresponding radius. We know the angle is given A to B, it is 45. Okay, so this is O point. From here you measure 45 and draw the next mass. So this angle is 45 degree. This is mass, this is A, this is B. Okay, corresponding radius. So next one, B to C, it is 70. So this is B mass. From B to C it is 70. So I am going to draw here. So this is mass 3. So this angle is 70 degree. Okay. Next, C to D, it is 120. So we have C here, and if we measure from here, the 120 will be somewhere here. So this is mass 4 and corresponding radius. This is 120 degree. Okay. So this is representation of masses in terms of angle and representation of masses in planes. Okay. Now, next step we will see. So I told you, first one given data, second one position of planes, third one position of masses. Next, we have to assume the reference plane. Okay, from the position of planes we have to fix, that is from the reference plane, left side negative, right side positive. We will see here. So here you can see the angular position of masses. Okay, I told you this will be the origin point. From here horizontally you have to fix the first mass, followed by the corresponding angles, mass 1, mass 2, mass 3, mass 4. Okay, and this one represents the position of planes. So as per the given example, the dimensions are mentioned here: mass A, mass B, mass C, mass D, and these are the balancing mass plane. Okay, X and Y are the balancing mass plane, and I told you we have to assume the reference plane. So you can see here I have assumed this X plane as the reference plane. From the reference plane towards left side you have to consider as negative. From the reference plane to the right side you have to consider as positive. Okay, it is not that this should be reference plane. You can assume this also as a reference plane, but for this example I have assumed this x plane as the reference plane. Okay, so after completing this reference plane, position plane, next step is you have to form the table based on the mass, radius. You have to form the table to draw this coupled polygon and force polygon. So we will form the table. Okay, I already mentioned this table. You can see here, you can see the values also. Okay, the corresponding plane, mass. Okay, the planes are A, X, B, C, Y and D. Based on the position of plane, you have to write this one. And the mass, we know, mass A 200, and this plane is the balancing plane, so we have assumed as mx. Then B mass, C mass, and this is Y plane, balancing plane, so I have assumed as mass Y. Okay, and D is 200. Similarly, corresponding radius of each masses. Okay, so this will be given in terms of millimeter, you convert into meter. Okay, similarly for all this you have to form here. So next column is important. It is, you have to find the centrifugal force. Okay, we know the centrifugal force is mass into radius into omega square. Okay, so to form this table we divide this in terms of omega square. We need only mass and radius, so you divide this with omega square, you will get only mass and radius in terms of kilogram meter. Okay, then you multiply this. So for understanding I will put this as 1, 2, 3, 4. Okay, now multiply 2 column and 3 column, and you have to complete the 4th column. Okay, so 2 into 0.08 you will get 16. Similarly m into 0.1 mx, 3 into 7 21, 4 into 6 24. So multiply column 2 and column 3, you will get column 4. So next column is 5th column. This one, distance from the plane. Okay, so distance from the plane, you can see here, this is position of plane, distance from the plane, this is reference plane. From here left side, A mass is at 100 mm, so you have to convert in terms of meter. At the same time, since it is on the left side, you have to take it as negative, and other masses on the right side you have to consider it as positive. So correspondingly you can see here, first mass, the distance is on negative side, so 100 mm. Then remaining mass, second one, since we are taking x itself as a reference, there is no distance, so we take it as 0. Okay, then for B, from this reference the distance is how much you have to calculate. Okay, so here from A to B it is 300, so here it is 100 minus, so you will get 200. Okay, so here you can see 0.2. Similarly for C, here it is 400 minus 100, you will get 300. Similarly for this one, 500 minus 100, you will get 400. So corresponding length distance here. Okay, 0.2, 0.3, 0.4 and 0.6. So last column is couple column, 6. Okay, so how will you get this couple column? It is a product of mass, radius and the length. Okay, and here also you have to divide it by omega square. We need only the couple values. Okay, and the unit is kilogram meter square. Now you multiply mass, radius. Already we have the mass, radius here, so directly multiply 4th column with 5th column, you will get to the 6th one. Okay, so 16 into minus 0.1 will give minus 1.6. This negative value is because you can see from the reference plane, A is towards left side. We have taken reference plane towards left side as negative, so this value will become negative. So that is why it is minus 0.1. Okay, it is in terms of meter. Similarly, 0.1 mx into 0, this whole term will become 0. Then 21 into 0.2, you will get 4.2. 24 into 0.3, you will get 7.2. 0.1 mx, my, 0.4, you will get this one. Similarly, 16.0.6, you will get 9.6. Okay, so up to this, once you formed, the next step what you have to do is you are supposed to construct the coupled polygon and force polygon. So in order to balance, you need to draw these two diagrams, but the condition is it depends on number of unknowns. So in coupled polygon column, you have to check the unknown. Similarly, in forced polygon column, you have to check the unknown. Which column is having the least unknown, that you have to draw, either coupled or forced polygon. So here you can see this is centrifugal force column, this is coupled column. So from this to fourth column and sixth column, check for the number of unknowns. Here you can see how many unknowns are there. Here it is one mx is one unknown. Similarly, my is one unknown. When you check the sixth column is this one. So here this is totally 0, so no problem. So here you can see only my. So here in coupled column you have only one unknown. Okay. So since the sixth column, that is coupled column, is having least unknown, so first we are going to construct the coupled polygon diagram. Okay. So coupled polygon diagram first we are considering based on the least unknown. Okay. 1 second.